Welcome to this FirstEDA video production. Introduction to Jenkins, using ActiveHDL with Jenkins. I'm your presenter today, David Clift, an Applications Specialist at FirstEDA. In this presentation we'll be looking at a number of things. First of all, what is Jenkins? Then we'll look at installing Jenkins on a Windows machine, post-installation configuration, and then adding an ActiveHDL project to Jenkins. So Jenkins is a continuous integration tool, sometimes referred to as a continuous deployment tool, and it allows continuous development and test of your HDL code. The idea being that as your code is submitted to your source control system, the Jenkins environment will check that code out and run all the necessary tests that you've described for that code, so that you're always testing the code. So when you reach code completion, you should have a fully tested and integrated set of HDL files ready to go on your FPGA. Jenkins itself is an open source tool written in Java. Along with being open source, it has many plugins that can be used to customize the environment to do specific tasks. Again, all these are typically written in Java and are all open source. By using Jenkins, we can move the verification load off a user's desktop to the continuous integration server. So an engineer can complete writing a piece of code, submit it to the server via his revision control system, and have it tested fully in the background while he continues with other work which doesn't load his machine so much. And the main benefit of this is that the tool itself, Jenkins, provides continuous feedback during this period. So if you submit code to the server that then breaks the tests that are defined, that user will be notified immediately such an occurrence happens. Now that can be email or via reports, and these sort of things are configured using the number of plugins. So when a developer submits something that does have unintended consequences, he can see immediately that his code was at fault and go in and correct it, rather than waiting to getting to complete code integration and finding that there's an error and then having to sift through all the source code to find where that error was generated. So what is continuous integration? We've really described most of what's happening with our continuous integration server, but the idea being that we can see here we commit changes to our HDL source to our revision control system. Now that could be SVN, or it could be Git, or a number of other popular revision control systems. That code is then checked out by the integration server, and we can run a number of tests. Now here I've highlighted running design rule checks on the code and then running HDL verification. We could do further processes like synthesis and implementation. Any of these failing or giving unexpected results will cause the generation of feedback, which will be fed back to the person who created the last commit to the database. So on the grounds that if they've just committed code that has broken the build service, then it's most likely down to them that we need to do a fix. Right, before we set up Jenkins to run the ActiveHDL job, let's have a quick discussion of how we're actually going to use ActiveHDL. As we're all aware, ActiveHDL is an IDE for FPGA development. Obviously, as we're running this on a server, effectively a headless server, we can't actually use the IDE as we have no way of inputting the cursor commands with the mouse while it's running. So ActiveHDL has a console mode, sometimes referred to as vSim-SA or vSim standalone, that we can use to run simulations in a batch mode. So to work with Jenkins, we have to create a script that allows us to run ActiveHDL in batch mode. And you'll find that alongside the vsimsa executable, which can run in console mode, which will execute all the major commands that you need to compile libraries and run simulations. You also have the DOS level commands such as vlib and vmap for making your library, vcom and vlog for compiling both your VHDL and Verilog, and of course vsim to actually run the simulation. Now obviously, because this is running headless, we won't have any graphics displayed. All we're doing is collecting the results. We may actually want to collect waveform data for later review, and if we're going to do that, we need to add some log commands into the script to capture any signals of interest. So let's have a look at installing Jenkins on our Windows 10 machine, and then we'll go through and set up a very simple project. So the first step is to install the Jenkins server on our machine. So we'll open up a website and we'll go for Jenkins download, and what we're looking for is the jenkins.io website. So if we click on that, this is the downloads page, and you'll see there's a list of downloads for different operating systems. So we're after Windows, so we'll click on that and start the download. As you can see, that's running on the left hand side. It's a 120 megabyte zip file, so we'll just wait while that downloads. Okay, so you can see here that the zip file has downloaded, so we'll open that, and that contains a single MSI file which we will execute. And just click next, select the installation directory, and then install. So the initial installation of Jenkins has finished, so we'll click the finish box to dismiss the installer, and this will automatically launch the Jenkins server on our local host. So we have this. The installation has built an admin password in a file, so what we need to do is open that file in something like Notepad. So let's open that, and in there is the password for the admin user, so we can copy that. Obviously remember to change the admin password once you're in to Jenkins. So we'll log in, and now the first thing we need to do is customize our Jenkins installation to install the necessary plugins that we need. And what I would suggest for your first initial installation, just take the selected plugins, so click install selected plugins, and you'll see this will work through installing the various plugins for things like the timestamper, the folders application, the SVN and GitHub integrations, and the ability to run SSH slaves. So it takes a while for this to run, but we'll come back to the presentation once all these plugins are installed. Okay, so the plugins have installed, and we need to create the first admin user, and we'll call, in this case, this user Clift. We'll give it a password, and we'll confirm the password, give it the full name, and a password, an email address, and save and continue. You can see we have the local Jenkins host that we're working with. We'll save and finish, and click the Start Using Jenkins. Now this will return us to the Jenkins dashboard, and from here there are a number of things we can do. You could click on the people and add in more users, so at this point we'll leave just the single user. We can also go to the Manage Jenkins tab, which will allow us to configure many things, including adding in more plugins, configuring the system, setting up system logs, and managing nodes within your Jenkins network, but all those are things for possibly a later video. So I'm just going to return us back to the Jenkins desktop, and we'll look at creating a new job. We'll click Create Jobs, we'll give it a name, example 1, and we'll create a freestyle project. Now we can give it a description if we want, but first of all we'll need to access the source of the project. Now for my example, this source is in Subversion, so you can see I need to specify the repository. Now if I check my Subversion repository browser, I can pick the location of the project I'm interested in. You can see in here there's a source file and a test bench and scripts. We'll pop that in there. We need to add in my credentials to access the code. We'll leave everything else as is. Build triggers. Here we can set up when we actually want the project to be built, so we can ask it to build periodically. By default there are no schedules in here, but these are specified in cron format. Or you can poll your source control mechanism on a scheduled basis, or you can actually get it to run the build environment every time there's a successful commit, but for now we'll leave that unset. What we want to do now is tell it actually how to build our project. So we're going to execute a Windows batch command, and first of all we need to go into the scripts folder, and in there we need to execute the build script that's in there. So we put in the script we want to run, which in this case is called perform simulation.bat, and we save the project. Now to test this we can just ask it to build now, so we'll click build now, and you can see the job has started. We can go and have a look at the console output, and you can see here if we scroll back through the console output, we're checking out the project, we're running through the compilation using ActiveHDL, and you can see at present the simulation is being performed. So we'll return to the dashboard, so we can see the build executor is showing that we're actually running. It's just finished, and the dashboard will update. So look at the console output, what happened. So we had a simulation success, so there, okay. So now the dashboard is updated, so the blue moon shows we had success. Build is currently stable, well we've only run it once, and we have some specs on when it was last run and how long that actual test took. And obviously we can go and have a look at the console or the build information, or we can delete this build from here if we want. So in conclusion, we've seen that Jenkins is an open source Java environment for continuous integration or continuous deployment. The Jenkins environment will provide you with continuous feedback as you add new code or update code to your design. So if you add code into your source code repository that causes your test cases to fail, the user who added that code will be notified, so they can go in and fix the design. Although today we've been looking at Jenkins running on Windows with ActiveHDL, it's also available to run on Linux and can be used with the Riviera Pro or Alint Pro tools from Aldec. ActiveHDL, when running in Jenkins, because we're in a sort of headless server type environment, we need to run it in script or console mode. So we need to script the activity that we want ActiveHDL to provide, i.e. the compilation and the simulation and capturing of any results that are required as part of the simulation run. And that concludes our video presentation. This hopefully was the first of a series of videos on using Aldec tools with Jenkins. We hope to bring you a further video showing how to integrate design rule checking, how to run Riviera Pro on a Linux platform, as well as discussing reporting within the Jenkins environment using some of the Jenkins plugins. If you have any further information requirements, please feel free to look at www.firsteda.com or contact us at sales@firsteda.com. Until the next time, goodbye.